Before moving into the modeling phase, the data first needed to be cleaned and the total number of variables in the dataset reduced. One example of a process used to clean the data was the replacement of encoded values which corresponded to nulls with nulls. While some of the process used in variable reduction included the removal of columns that were missing large amounts of data, as well as the removal of columns with no variance and those which were highly correlated. As you can see here, the shown 9 workflow contains all of the processes that were used in the data preparation stage. Starting from the left, joiner nodes were used to combine the 3 previously mentioned data files. Next, the target variable, injury severity, was filtered so that the data set only included rows with an injury severity value of 1 through 4, since the other values within this particular variable weren't relevant to our analysis. Afterwards, the data was once again filtered, this time based on the variable for seat position. The goal of this analysis was to predict the severity of injuries sustained by the driver and the driver alone, meaning we only needed to include rows where the driver was the one injured. The encoded value used to represent the front left seat of a vehicle, which is the driver's seat, was the number 11, so the rows in the dataset were filtered by this value. The next node in the workflow is what's known as a composite node, which is the node that's just been visually consolidated and contains multiple processes. The first composite node contained math formulas, which these were used to replace encoded values with nulls. Each variable in the dataset used a slightly different encoding scheme, meaning that we couldn't just use a single math formula node to correct all variables in the dataset. In order to analyze the amount of missing data in the dataset, these various null values were replaced with blanks, and then once we'd done this, 9 was able to recognize which cells were actually missing data. Once all the variables in the dataset had been converted, columns that were missing at least 25% of their data were dropped from the dataset. As you can see from the next node, the target variable, injury severity, was then binned into 2 bins. One was a high bin, which contained injury severity values of 3 through 4, meaning cases that had either severe or fatal injuries, while the other bin, low, contained cases with low or mild injuries, so the variable values of 1 or 2. The goal of predicting cases with severe injuries was why the team decided to bin the target variable, since we weren't really interested in the differences between individual stages, such as, say, the difference between level 1 and 2, or the difference between level 2 and 3. The next node used was a low variance filter, which was used again as part of variable selection. The low variance filter was used to sort out columns which had 0 variance, meaning they had the same value throughout the dataset. If there's not any change to the variable, it really isn't much use to making predictions, which is the logic behind why such variables were dropped. Then, a correlation matrix and a correlation filter were used in Tangent to drop columns with a correlation coefficient greater than 0.7 to avoid any issues with collinearity. So as of this point in variable selection process, there were still 57 variables in the dataset, which is a pretty great drop from the nearly 200 we'd started with. Since the team still wanted to reduce this variable value further, though, a forward selection loop was utilized. The forward selection loop uses a naive Bayes analysis and checks the accuracy of the model based on different combinations of variables. The forward selection loop was set to choose the 25 predictor variables which best provided an accuracy level for the model. The final variables which were selected by this loop are shown in the table below, called final variables. So as you may have noticed before, there were actually 2 composite nodes used in the analysis. This second composite node was used to convert the categorical variables remaining after the selection loop into string variables, since originally all variables had been made with encoded values, which means they registered integers. Afterwards, there were only 2 minor changes that were made before moving into the modeling phase. The first was to create a variable known as winter, which checked if the month of the accident was November, December, January, or February. The second change was made to convert the variable model year to a slightly more friendly format. This was done by subtracting the values of the model year column from the year 2017, which was the year the data was recorded. The resulting variables, which the first one was called winter and the second was called vehicle age, were both used in place of the original values in the dataset. As of this time, the data was ready to be exported to a separate file, which we would then import and use in creating the models. This method was used to prevent any kind of changes from occurring accidentally to the data preparation modules used here, so it could be consistent with our outputs.